do this. First thing I have for somebody is a review question. I have circle O up on your screen right now. It's not in your notes, just up on your screen. Circle O. So I know O is the center. What have we been calling angle AOB? What type of angle is AOB? 16. Kyla, what type of angle is AOB? That's a central angle. Good. How'd you know it was a central angle? The vertex, right? The vertex of the angle is the center. So I call that a central angle because today I'm going to move that vertex somewhere else and it's called a different type of angle. Last thing I need, the measure of that central angle AOB. How do I find it? It's the same as what? 12, Lucas. Measure of angle AOB is the same as what measure?
Arc AB.
Yes, the central angle is the same as its arc measure. Okay, so we just wanted to review that because I'm going to go into a different type of angle right now. Questions on the central angle? We've been talking about it for almost a week now. All right, so what I want to introduce to you today is not a central angle, but what's called an inscribed angle. Inscribed. Now the vertex is on the circle somewhere. So what I want you to do right now, take your pen or pencil, your stylus, put a point somewhere on that circle I gave you. Put a point somewhere on that circle. Anywhere on the circle. Not inside, on the circle. So you guys put a point somewhere on the circle. And what I'd like you to do now is that's the vertex of the angle now that you're going to create. So everyone draw in an angle coming from your vertex now. You have just created what's called a central angle. Inscribed angle. Get my facts correct. That is called an inscribed angle, where the vertex is now on the circle. But, hold on. The angle has to be formed by two chords. That's great. Take a look. That's great that my vertex is on the circle. Watch what I can do, though. Here you go, kids. Ready? Watch this no-go here. Please do not draw this. That's not inscribed. Why not? Oh, yeah, I get it. The vertex is on the circle, but is it formed by two chords? No, it's a radius and a chord. That's no good. The inscribed angle has to be two chords. Here's another non-inscribed angle. One's a chord, the other's not. That's a problem. Okay? Both sides need to be chords. What do you guys think about this one? Is that an inscribed angle? What do you think? Yeah, because the diameter is a chord. All right, so both sides of the inscribed angle have to be chords, and the vertex has to be on the circle. Everyone all right with inscribed? All right, now how do I find the measure of it? Because remember, central angle, it was equal to the arc. Well, inscribed angle, half the arc measure. Half the arc measure. Okay, so inscribed angle, your first theorem here today, inscribed angle is equal to half the arc measure. All right, half the arc measure. And just to give you guys kind of like a number, like say if this arc measures 70 degrees, the inscribed angle that's formed by it would be 35. Okay, that's how it works. Half its arc measure. All right, what do you say? We get after it a little bit here? Okay, first one, I got a triangle inscribed. I put in what it meant in parentheses, but we know already. If a figure's inscribed, the vertices touch the circle inside. A is 80, arc AC is 88. You guys ready to rock and roll here? Find arc BC. Arc BC. Everyone agrees that angle B, A, and C are all inscribed, correct? So I find them by taking half of whatever the arc is. Well, BC belongs to what inscribed angle out there? Arc BC belongs to what one of the three inscribed angles? Which one? 11. Here we go. Anthony, going to you. Arc BC belongs to which inscribed angle, Anthony?
Angle BAC.
Angle A, right? Everyone agrees? Inscribed angle A is drawn to arc BC. Well, how did I find that 80 then? I found 80 degrees by taking half of arc BC. So what do you think I suggest I do to find the arc now? I don't want to take half of 80 again. Instead, go in reverse and multiply it by 2. Correct. So if you want to find arc BC, that's going to be 80, its inscribed angle, times 2. So that's 160 degrees. Arc BC. All right, what about angle B? Everyone agrees angle B is inscribed. So the rule is, if you want to find an inscribed angle, take half its arc. What arc belongs to angle B then? 18. Owen, what arc belongs to angle B?
Arc AC.
Which I already know is 88. So I'm just going to take half of its arc, 88, and I'll have my inscribed angle, 44 degrees. All right, good work so far, guys. Good work on the basics. All right, what about angle C? And remember, I don't need circle facts every time. If you can get to it another way, get to it another way. All right, angle C, what's your thought? Talk to me. How can I find angle C? 10. Atticus, how can I find angle C?
You can subtract 88 and 160 from 360 and divide it by 2.
Okay, there you go. He's saying, all right, there's 360 degrees in every circle. I have 88, I have 60. That must mean there's 112 left for arc AB. And angle C is drawn to that. So I'm going to take half of 112. And angle C should have been 56. If anybody out there was thinking, oh, I know 2 out of 3 angles in a triangle, subtract them from 180, you're correct. And then I guess Atticus also did part D for us as well. Finding arc AB, 112 degrees. Any questions on the basics of an inscribed angle? Half its arc. All right, let's get a little bit more complex after we got the basics down. I'll let you guys take a look here and soak this in. Find the value of A and the value of B. I'll have enough information to find one of them, but not the other. All right, you do have enough information to find arc PT, which is labeled as A. Does anybody see an angle, an inscribed angle that is drawn to arc PT, which is A? Do you see an inscribed angle that is being drawn to arc PT at all? Where is it? 15, here we go. Will, do you see an arc or an angle that's drawn to arc PT?
Angle PQT.
Yep, which is how many degrees?
60.
Everyone see that? This 60-degree angle here, PQT, is being drawn to arc A. An inscribed angle being drawn to arc PT. So instead of taking half of 60, which is arc PT, I'm going to take 60 and double it. So that's a 120-degree arc. Not too bad. That's not the reason I want to do this problem. The reason I give this problem is for B. Making sure you guys know what the arc measure is. Everyone agrees B is an inscribed angle? B is inscribed. So it's going to be equal to half its arc. Ooh, but now I'm not given the full arc measure. I actually got to add up a couple arcs to get there. What's up, Kyle?
What is measure or 30 degrees? What does that show?
TS.
Okay.
The measure of arc TS is 30 degrees. That's what that's showing there. All right, so if I go, I'm like, all right, angle B is inscribed, so I'm going to take half of an arc, right? But as you guys notice, that arc is kind of split into two. So I just can't take half of 120, and I just can't take half of 30. I got to take half of both of them added together. Does everyone see where that arc is? All right, angle B goes from P to T to S. All right, that's the arc that it forms. So I just can't take half of 120. I got to take half of 120 plus 30. So sometimes, yes, you will have to combine arcs first before I take half of them. So you end up with half of 150, 75 degrees. Questions from you guys? All right, you guys are going to come up with the next theorem now. All right, I'm going to give you a drawing, and I'm going to have you guys think about what must be true about it. So here's my diagram. And you guys don't have this if you want to jot this diagram down, you can. If not, it's fine too. I just didn't give it to you. All right, so I got my center here, my circle. Here's my diagram. I'm going to have a couple chords. And we'll go, let's see, A, E, C, D. I know the vertical angles are congruent. I got that. I'm pretty good at this stuff. Vertical angles are congruent. What do you know about angles E and D? And make sure you back yourself up with a reason. Okay, so if you're guessing, maybe you'll be right. And I'm not going to call on anybody here, but what should I know about angles E and D? You think you know, Hannah? And can back yourself up.
Yeah.
Okay, talk to me.
Would they be congruent because they form the same arc?
Okay, here's what Hannah said. They're congruent, which is correct. And she said they're congruent because they form the same arc AC. All right, let me put some stuff in between there. Yes, they are congruent. What type of angles are they? Inscribed angles. How do I find an inscribed angle? Half its arc. What arc is E drawn to? AC. What arc is D drawn to? So aren't I just taking half the same arc? So I should know that E and D have to be congruent because I'm taking half the same arc measure. Make sense? Same thing can be said for A and C, can it? Look at A and C. Are they both inscribed? And what arc are they both drawn to? ED, yes. And that is the theorem I'm going to write in here. If you have two angles, two inscribed angles, drawn to the same arc, they are congruent. Does everyone see how that works? E and D, both inscribed, so I would be taking half of the same arc, AC, so they have to be congruent. So two inscribed angles drawn to the same arc are congruent. Good job, Hannah. And I got a bonus question too. I'm going to catch a lot of people on this bonus question. Two inscribed angles drawn to the same arc are congruent. Here's my bonus question. What do I know about the triangles? Watch your mouth. You think you know, Audrey?
They're similar?
Similar, not congruent. I don't have any sides. I don't know any sides are equal. All I know is that all the angles are equal, which makes them similar. Yep, good job. They are similar. All right, everyone all right with that theorem? All right, I got a couple more when we're almost done here. All right, nice little diagram here. Can I get a little help finding X, Y, and the measure of arc BC? And I'm telling you so you don't have to guess or ask. AB is a diameter and ABD is a straight line, if that helps. Let me start with X, angle X. Angle X. Don't tell me the answer. Don't tell me the answer. In the circle, what do we call an angle that looks like X, where the vertex is on the circle? Angle X is still what type of angle? Don't give me the answer. Ellie, what type of angle is that in the circle, X?
Is it an inscribed?
It is. Good job. Inscribed. And do you see the arc that it's being drawn to, Ellie?
Is it arc AC?
Well, here you go. Here's angle X right here. Do you see the arc that's being formed in between it? Arc A to what?
B?
Yep. All right, this is going to be a challenge, Ellie, but I know you can handle it. Previously in this unit, we've had a name for this type of arc, AB. And remember, AB is a diameter. Segment AB is a diameter. Do you remember what we called that type of arc from A to B?
No.
Half a circle. A semicircle. All right, a semicircle. Do you remember how many degrees? This is my last question, Ellie, I promise. Do you remember how many degrees in a semicircle?
Is it 90?
A little bit more. Remember, how many degrees in a full circle?
360.
So if you take half of that, it'll be what?
180.
180. Does everyone see how? Thank you, Ellie. Good job. Everybody see how angle X is being drawn to a semicircle? So yes, I am going to take half because it's inscribed. So the rule is take half of that semicircle, 180, and you will end up with a right angle. And that's true every time. Hey, that's true every time. And that's what theorem number 1 here says, is that if you draw an inscribed angle to a diameter, it will always form a right angle. Okay? If you draw an inscribed angle to a diameter, it will form a right angle. And yes, these are facts we're going to put in proofs later on in the unit when we get back from break. All right, you won't put them in the proof on the quiz, but later on after break, when we do more proofs, you'll see this used. All right, how about Y now? Angle Y. Well, wait a second. Isn't Y inscribed? So it should be half of arc BC, but I don't know arc BC. But maybe there's a different way I could get Y instead of using circles. Quincy, thoughts on how to get angle Y?
Well, maybe you could use angle BBC, but I'm not sure how.
Okay, I think you're just you're overthinking it.
Oh, you could just add the angle.
And subtract from what?
Yeah. 180.
There you go. Right, triangle ABC, 180 degrees. I already know one angle is 90 from the first part, and it was given to us that the other angle is 58. There we go. And now I'm looking at 32 degrees. And then finally, find the measure of arc BC. Find the measure of arc BC. Now, hopefully you can use our previous answer there. Can you give me a little help? How can I find arc BC now? 22. Anna, going back.
You can multiply the y by 2.
Yep. Take your inscribed angle we just found, 32 degrees. Double it. You'll get the arc, 64. Any other questions, comments? And the last theorem for today. Last theorem. And you may want to just draw a quick diagram here. Give yourself an inscribed quadrilateral for me. Inscribed quadrilateral. Any type of four-sided figure. Does not have to be a square, a rectangle, any four-sided figure. Just make sure all 4 vertices are touching the circle. All 4 vertices must be touching the circle. And you can throw some letters on those vertices. Throw some letters on. And here's what it says in a nutshell. If it's inscribed, the opposite angles add to 180. They're supplementary. So if D is 100, angle B, it's got to be 80. Okay, they have to be supplementary. Opposite angles, supplementary. That's a good one right there. And let's apply it. Let's finish class off with a little application of that theorem. All right, we got an inscribed quadrilateral. Angle D is 86. Can I get a little help finding arc GFE? GFE. G to F to E. Ooh, wait a second. Isn't angle D 86 drawn to that arc? All right, what are you guys suggesting I do with the 86 then to find the arc? Ooh, 21, Zach, what are you suggesting here?
You have to multiply it by 2.
Yep, take 86, the inscribed angle, double it to find the arc. Got it. 172 degrees. And what about angle F now? Here's the theorem we just talked about. If a quadrilateral is inscribed in a circle, opposite angles, in this case, angle D and angle F are supplementary. So 180 minus 86, 94. Opposite angles are supplementary as long as the quadrilateral is inscribed. Now, before I end class, let's say on the quiz this week you totally froze, or maybe you didn't study this theorem. Could I still have found out what angle F is? Yeah, ready? It's still inscribed. So somebody tell me, I'm not finished yet. What angle is formed by angle F? I mean, what arc? What arc is formed by angle F? Arc EDG, correct? Could you find the measure of the EDG? This one right here, EDG, could you find the measure? Yeah, you just knew that was 172, 360 minus 172, and then you take half of it. All right, so it is still possible. All right, remember, do not do the homework assignment tonight. After I go over the quiz topics tomorrow, you'll have plenty of time to finish the homework assignment. All right, I'll be after today, tomorrow, and Wednesday if anybody wants to use it to get ready for the quiz. See you guys tomorrow.